Good morning or afternoon or evening, depending where you're actually watching this. I think it's been actually streamed online. First of all, I would like to introduce today the new old topic in a way. The way that I actually pronounce is called DFEx in a way. It's just DNS file exfiltration techniques. So let me first of all clarify how the Q&A works now. You're all aware of the Slido app. To vote the best question, put the questions, you get free stuff. It's big plus actually. Please just put the question in. You don't need to wait for the end of the talk. So if you have a doubt, just put the question, then we can actually figure out the answers or no. But let's try to make it more interactive. And I do have some stuff as well to give. I will not say what yet, but if you get a good, difficult question, yeah, you probably get something then. All right, without further ado, let me introduce myself. I'm Emilio, or Emilio, depending how you pronounce it. In the language, I will take it. As I've been presenting tools and in various security conferences around Asia, US, Europe, few places actually. So just to make sure, I'm not a native programmer. So the code that you may see is probably it just run. So if it runs, it's okay, as long as it runs. That's what I've been doing. And then if for some reason the English doesn't sound right, just correct me when I'm wrong, please go ahead. All right, what is DNS file exfiltration, aka DFEx? Well, what we try to do here is to use DNS protocol, a very standard and common protocol, to actually as a cover channel. So the whole idea and pointer is to be able to transfer files without using a FTP, secure copy, or any transfer protocol, Samba, whatever. We want to use DNS as a transfer file mechanism. So why? Because it's commonly allowed and also is actually very useful for post-exploitation. So basically, once you get access into the network, you want to take files out. So which approach do we take here? It's very simple, actually. It's just hiding blind sight. So what we do is we try to put the file into just DNS as it is. That sounds very simple, and I will walk you through, which is actually not that simple. But the whole idea of this is to avoid getting detected. So the mindset was, okay, I need to exfiltrate files. Firewalls are getting really smart these days, potentially. And they have IPS and all these kind of products you normally go out and bite to detect this stuff. So and they say, let's look around how we can do about it. So, I'm not going to go into detail, but I'm pretty sure everyone is aware how DNS work. You make a query, you get an answer. I don't think it's simple than that, theoretically, right? However, within the protocol, there's a lot of stuff inside, right? This is just an example of how just basically DNS tunneling, right? Which I will cover later on. So what we have in the market, right? So today, when you go and try to exfiltrate files or data through networks, there's many tools available. And actually, if you see, I will categorize in two different sizes. One is the exfiltration, like data exfiltration, and the other one is tunneling, which is normally to bypass firewalls. So all of these are, open source tools that you can go and take a look at it. What I did notice is most of these tools are well-known tools, and they are being catched by firewalls, that smart firewalls, right? Like, application detection, inspection. They actually been well-known use. So this is quite funny because it's just a dash different. They're different tools though. So what I come up with, like, okay, these are good tools, but I need to come up with something slightly different because I have different requirements. So what I started to do was, okay, so let's write down what I want, right? I want something like this. I want to have 256 CTR encryption. I want to have capabilities of retransmission, like any good protocol in a way. I want to have error-free. Yeah, definitely want to see error checkings, threading, speed, multiple domains. This is very important. Why I want multiple domains? Most of the tool works in you just tell the tool which domain DNS are you using, and the tool will actually use that one. That's very easy to catch because you will see hell of a traffic to one domain. So to avoid that, I want to be able to multiply that for X amount of domains. So that's the reason I want to have that, to avoid being indicators of a... Normally, if you get a DNS and the DNS is brand new register, you probably are in the list of suspicious already. So if it's an old DNS registration domain, you may be okay. Also, I want to be stealthy. So I don't want to be found by IPSs or smart firewalls. And last thing I want to do is I want to go atomic. Atomic means one way. So most of the firewalls and IPSs work on as behavior, stateful connections. So as soon as you start to see pattern of traffic back and forward is when they start to classify things. Well, atomic packets means packets go out, nothing can be. So the whole concept of that is, so firewall, you will see stateful sessions timeout, H out in the logs, depend the firewall. In a IPS system, they don't see anything back, so they can't really correlate the information. There's a catch here. I want to be one-way packets, but I do want retransmission. So that contradicts itself. So I will go into detail how do I go around it, having a bit of both, basically, retransmission and one-way packets. So this is what I would like to have. Yeah. All right. How do we avoid detection? Okay. If you look for all current tools and around the market, and what you see is they have things in common. So they use TTL, very short TTLs, to be avoiding the caching on DNS. They use TXT records because they can fit a lot chunk of data on it for tunneling and for exfiltration. They have a very long DNS suspicious names. I've seen up to 100, but the 80 is probably not normally. And they have a high volume of the client hammering the server, basically, right? Because that's very suspicious when you see one client generating 20 megs of DNS throughput in 5 minutes. And the other thing is one server destination, one domain name. They're going to evil.com. Okay, that looks suspicious as well. So this is what I don't want. This is what I'm trying to avoid. So I'm going to go that way. I'm going to go and do, first of all, I want to split the control and data domain. Like any proper protocol, like switching, routing, you split the things. One thing for control, one thing for data flows. So I want to split the flow into different control and data domains, different names, one or more, multiples. I want to use NS query type, not TXT or A records. Why? Because NS query type is an interesting query type. First of all, it's not in common use or abuse. Secondly, it's recursive, so it will go further and further. So I do not want any reply back from data domains. So when I push data, I don't want anything to come back. Kind of. So I also want multiple domains. I want to be able to scale this into 50, 100 domains, 60, I don't know, you choose the number, for data or control. And I also want to limit the amount of a FQDN, the name query, to 20, 30 chars, you can choose, various. That will make an impact on the speed, right? How fast that transfer will go. All right, so I come up with an algorithm. Yes, I want to do all that, but I need to put a logic on it. So what I'm going to do is, okay, I got a file. I want to exfiltrate etc password, or any of the database or whatever you want. So I got a file. I want to do a CRC32. That is for error checking. It's no encryption, it's no security. It's just to make sure the other guy got it. It's just a checksum in a way. So I'm using CRC32. And also because I want to scale this, so I'm using a file ID generation that allow me to threading and actually process multiple files at the same time. So I'm going to compress it because it's a good idea. So then I'm going to generate a AES-256 CTR key. So basically I will, based on this, you put the client and the server with the same key and encrypt it, right? CTR, just for the sake of it. And I'm going to apply base 32 with custom padding. This is tricky because people will use base 64, right, for anything that goes through the internet. Well, it doesn't really work very well base 64 in DNS. Why? Because base 64 is lowercase, uppercase. And that's a problem with DNS, because DNS don't care. So I need to go down all the way to base 32. However, base 32 padding up to 7 characters at the end of the, whatever you are encoding, it will add equal signs. So that's a very distinctive way to know that this is a base 62 or base 32. So we'll add equals. So how equals in the middle of a DNS name doesn't make any sense. So how do I go around it? So the way to do that is, I know that it's 0 to 7. There's a maximum of padding that you can get. So what I do is very simple. So if my file has a 4 equals at the end, what I do is I put a 4 integer at the beginning of the file and strip the equals. So that automatically will not be able to do the base 32 because it's weird, already has a digit at the beginning. But that allows me to do proper DNS query with that name, and also in the server, the receiver, roll it back. Right, I will split the file, whatever that file does before, into 20 or 30 characters for the DNS. I will generate a source IP list for spoofing. This is key element. Why? Because as you saw in all the techniques firewalls, what they do is they see a source client doing 20 meg of traffic from one IP to one server. That's very easy to find. However, what I'm doing is, spoofing. It's a very old technique, used in the 80s, 90s, 2000, and 2019 as well. So what I'm doing is basically grabbing a /24 where I'm sitting in the network, or /22 or 23, generate the list of all the possible IP address, and source spoofing my DNS query to the internal DNS server. Why I'm doing that? Because that allows me to multiply the traffic, threading all at the same time. So from multiple sources. So that giving 2 advantages. First, push more packets out. Second, which one is the real one? There's no way to keep track which one actually is the real source generating those strange queries. So that throw away the guys from SOC. Could be anyone. Because there's no really, unless you have IPS in front on the LAN where the server or PCs are sitting, it's very difficult to detect actually which is the real IP doing the real queries. Could be any of those. I will send a control DNS packet. The idea here is, first of all, I need to tell my receiver to get okay, I'm going to send you this file. This is a CRC, and this is the amount of packet I'm going to send you, 1,000 of them. So once I send that control query, I will check it with the data queries, multiply by 254 IP address, the whole class C/24, and I will send the ID of the packet, the ID of the file, the sequence of the packet, and the chunk. Why I'm doing all this? Because this allows me to send multiple files at the same time. It doesn't matter which order they go all scrambled together. Sequence, I do need to reverse the order and put in sequence my file that was encrypted and chunked and padding. So I do need to know which packet it is. It's like TCP. You have a sequence number for a reason. And of course the data. And I will do that until it's done. Once it's done, I will actually back to my control retransmission packet. So I will say, once I finish sending all my data packets, I will send a control retransmission packet. And this is a trick, because if I don't get any answer, this is an A query. If I don't get any answer, that means the file was okay. However, if the server did not miss some of the packets, that means that something is missing. So he will reply back to me in a DNS A query telling me which packet was missed. So I will resend it until I give timeout. That process will keep repeating until there's no more missing packets. All right, so this is a question for the audience. It does look suspicious to you? Any of those 2 names? Yes, no, both? Left your hand, right your hand, I don't know. I will put it like simple. Well, yeah, probably. However, that is an actual real DNS entry from Cloudflare. That is actually true. That's where my PC goes to some website. I don't know, probably banners or ads or something. So that is actually a real web server that is actually. So if you take a look, what kind of name they are using? yeah, it's maybe X, I don't know, it's just random digits and numbers and letters in a way. So that is a real one. However, this one don't. That actually is the one that I'm using, which is a bit more longer in a way, but still similar format. So that's the whole point of it. Because I got a question about, well, this clearly is suspicious, right? When you see that, this indicates something going on. However, it's actually real traffic, this. Your PC, if you do TCP dump, you probably catch things like this going to CloudFront, which is the, I think it's a Google one, or the Amazon one, or one of the CDNs, actually. So that is, and you could go a slightly different version with dashes if you want to as well. So let me move into the control flow, right? So this is an example how the flow will go. I have my client, I got the internal DNS. That's my target. So what I want to do is I want to send the file all the way to my server, right? The control domain, what it does, it needs to be sent by the real actually IP. I'm not spoofing here. It's one single NS query with inoffensive name on it. So that will bounce again the root and the server, and eventually you will get cached by the DNS server that this control.domain is actually that server. That will be cached there, which is a good thing, right? Because, if not, it will be queried all the time. That's for the control. It's only one packet. And the funny part is nothing come back. So from the DNS, it will give you a timeout, basically. No records, NX error, I think it's called. So this is how the control flow will go. The thing in the middle with the, that's supposed to be allegedly a firewall. Very smart firewalls. How the data flow goes. So the data flows will go in the dat.domain, which could be 1, or could be 50 different domains. I don't really care. So the thing is, I will be sending the chunks from different source IPs, spoofed, right, to the internal DNS, and the internal DNS will be querying outside for that domain specifically. Nothing come back. There's no answer, right, on any of those queries, so there's no caching either. So what tends to happen is once I finish, I will send a retransmission packet, and if I do get an answer, that means that I'm missing something. In this example, I'm missing packet 07B8. The packet has a limitation. I will go into that into later details. But I'm missing a packet. So what I do is I do my seed. I reply back with 200.239.123.8 to this query. How I do that? Well, basically that is the seed, which I choose 200, dot ID of the file, which in this case was 239. And actually the file is to match the ID, and the 123.8 is actually the integer number for 07B8. So in that simple NS query answer, I'm actually asking, please send me back that one. And that process will repeat until I don't hear anymore. So when I make a query again and I don't get any answer, that means, okay, you got all the packets. So in that way, I'm trying to put it as a minimum or retransmission, because this ineffectively is that answer you see there is the retransmission answer. Only use it when you actually need the packet. So I'm trying to, as I said before, send atomic, but if I do lose a packet in the way, I need the answer. So that is the mix of the two ways. So within the 200.239.123.8 is actually encoded my packet missing. Please send it back. So this gives you an overall of actually itself how the flows goes on the packets. So this is a real example. So the control packet, we have that format, which is EF is the ID, BBCCDD is the CRC, is fixed to 6 characters, right? The ABCD is basically the amount of packets. So I'm using up to 4. That means 35 amount of packet possible in a file. We'll go into limitations later on. So then, once I send my control packet, I will start sending my data packets, right? And the data will have the ID, the sequence number, which again go from 1 to 65535, the data chunk, and the domain, the data domain. this can be multiplied by any amount of domains. For retransmission, I'm sending the file ID and the sequence 0. If I get an answer, that means I'm missing something. If I don't, we are good to go. So in that way, we try to combine a bit of everything here. All right. So this looks very nice, but actually works? That's a good question. Because the first time I say, okay, this is a good hypothesis, you need to do it practical, right? So I decide I'm going to build the environment to test it out. So in case you're not aware, Macaroni is actually this box here behind me, or next to me actually, which is basically infrastructure in a case. Because Cisco switches, servers and firewalls, etc., which is easy to carry. So what you're seeing here is what actually you will see, right? It has an internal DNS server, firewall, server, and a client, basically. All built with some Raspberry Pi, Cisco stuff, cabling. So I'm going to try to see that this actually works or not. So what I did at the beginning was do some testing in Python. And then I found out that I was really good. I was testing a loopback. Yeah, in real life, it's not a loopback. So I went into the actual infrastructure to realize how it works. And I found interesting things on it, which is probably part of the behavior of the normal infrastructure. So proof of concept. So demo or go away. It's a very nice theory, but we actually need to show it, right? So let's see if it works, because it's a live demo. It's no video. It may not work. You know how this works. First of all, can you see? Yeah? Hopefully. If not, let me know and I will zoom in. So on the top is an internet server, could be VPS or anything in the internet, right? With the server software. On the bottom is the actually client, right? Which is your internal server or client that you took control of it. Just remember, most of the stuff is designed to post-exploitation. So once you get control of this, you want to take files out. So first of all, let's see if we can start the server, right? The server itself has just a few parameters. I can put it in verbose mode. Maybe I can't remember what verbose does. You specify the interface. Now, you need to specify data domains and control domains. So I have two switches. Basically, you can specify just one, control, one data, or you can give a file with a list of it. So let me see if I have, for example, for control domain, I have a file with one domain. For data domains, I have a file with 1, 2, 3, 4, 5. Right? So let's use those. Those, of course, server and client need to match. If not, make no sense. So let me bring up the server, verbose, interface, and let's use control data domain. Data, control domain is this one. That's it. So let me run the server first, then we'll write debugging. So 200, 200, 200 is my actually interface IP public, which is only in the lab, right? No, actually, I don't know who owned it, to be honest. Didn't ask. So in the client side. So in the client, yeah, this is a client. It's very similar features. You still need to specify a control, either file or domain specific and the data and the interface. But of course, you need to specify a file to transfer. Or you can specify directory. So if you specify a directory, it will grab all the files there and push them out. So that's designed to basically push directories out with all the files. Then I have a few features here. I can control which DNS I want to send it. I could use the one on the system, or I can specify one manually. So if I don't specify, it will use the one in the system. And also I could specify the network. So for example, if I don't specify the network, it will grab the network I'm in and the netmask I'm in. However, if I want to make it bigger, I could specify the network and the supernet. For example, if I'm in /24, I do S3, that means it's going to become a /21. Why this is important? Because that's for spoofing. So that means that I could amplify the amount of packets sending at this is threading, so all at the same time. So I can multiply my source IP address, fake source IP address, I'm sending data. So this is like ADSL works, the upload and the download. Remember, you're pushing data out, so you don't want anything to come in. So it's asynchronous, basically, transfer. So you want as much packet you can send at the same time from different source IPs. That gives you a different speed. And that's it. That's the only features that, and the file, of course, or directly. All right, so let's give it a try. Interface, we say data domain is the file and control domain is, this I'm specifying, I think is 5 data domains, 1 control, and DNS, I will specify this one, and a file. Right, so I'm going to send the shadow, right? So once I hit enter, right, it will grab the 254 IP address of the class, the network I specify. So the file ID is 90, right? So what that means is actually they just generate from 0 to 255. So just an ID. So, and then he chunk it and he send a retransmission packet, nothing come back. So he believes that it's all good. Now, if I go to the server tell me that he's receiving a file called shadow, and this is a CRC32. And if you check the CRC32 on the server, it's actually the same one. So in this case, there's no retransmission. That means that file got sent, it probably took a few seconds, I guess. It's a small file, right? So what tends to happen is, once this works nice, but what happens when you send bigger files? And that could be an issue, because there's some limitations on the amount of big of the file based on the sequence number. Remember I mentioned I'm using within the sequence number, I'm using from 0001 to 65535. Why? Because that is my actually limitation. So what happens if there's a file with 70,000 packets, chunked, right? Well, it doesn't fit. So there's a limitation that it's around 4 megs to be around specific. You always could chuck the file as well in 2 pieces if you want to, with a split command in Linux. But the limitation comes in the 4 digits that for sequence number. So it's around 4 megs limitation files. So anything bigger than 4 megs, you will need to chunk it to actually be able to send it. So again, the whole concept of this is to be able to send files. So let's try to send something bigger. So I'm going to send a different file. Yeah, this one, customer DB, which what tends to happen when you send bigger files, and this is DNS nature. So again, I just took file ID 25, and there's 1,900 chunks, right? So that means I'm going to do 1,900 queries, basically, right? What tends to happen with DNS, because it's very inefficient protocol, things get lost. So this is by nature. So this is where, even if I did not in purpose lose packets to test the retransmission, this start to happen. So this is where the retransmission actually help, because in the nature of DNS, you lose a packet, it's constantly retransmitting, re-asking again DNS. In my case, a packet make a hell of a difference, because I will not be able to decrypt it, decode it, or anything actually, if I miss one single packet. So this is why the retransmission is a key element and feature that I needed. And this is going to take approximated 3 minutes. So I will take questions right now, because nobody want to wait 3 minutes waiting for something to finish. So if you want, in the meantime, or we can all be in silence if you want to wait in 3 minutes. But we can take some answers from, some questions from.
Yeah, Emilio, hang on a second. What we'll do is perhaps throw it open to the floor and then give them priority. And then if not, we'll come back to Slido. Is that okay?
Yes, perfect.
Any questions for Emilio from the floor? Yes, ma'am. Here in the front. She's gunning for her 3rd best question prize in 2 days in a row.
Given the precautions that you've stated earlier, like dividing it from different subdomains and not sending more requests, like limiting it to 20 to 30 requests. What is the best way to actually detect this type of attack since you are aiming to be in stealth mode?
I will answer in a simple way. I have that answer in the next slide.
Okay.
But if I did that, it's like spoiler alert, right? But I do have that answer, actually, kind of. It's part of the conclusions. I do. It's a good question though. But yes, I thought about it. So I put it down. The answer, right? So.
Do you want to answer it now or
No,
later?
because that is a conclusion closing.
Okay, okay. So you want to leave that till last?
Yes, but I do have an answer for you. I will
Okay.
remember it.
All right.
Don't worry.
Any other questions from the audience?
It's only a minute and a half left.
No, actually, you have 29 minutes left.
No. For the testing to finish.
Oh, for the testing to finish. Okay.
Right, we could all be in silence waiting for a minute and a
Okay,
half again.
understand.
Or just go
Okay.
to some
Any
questions.
more questions? If not, we'll take the first one from Slido. The most upvoted one. Wow. 7 votes.
In addition to detect DNS standard on next generation firewalls, is there any other way to detect or defend, especially on the cloud?
Yeah. On AWS or Google Cloud.
That's a very good question because yes, next generation firewalls do application intelligence. So they actually look for protocols and they will see that it's doing iodine for DNS standard and things like that. However, in the cloud, it's a bit tricky because, for example, Azure cloud, right? You get the private cloud, you get the access to your private cloud, you build the servers, and then there's one small details. Those servers has DNS access. Even though they're not actually in internet, they have DNS resolution working because that's the essence of the cloud. All those VMs that the cloud provide to you, they need to work actually to be built, to start to work, to provision, they need DNS. And what tend to happen is Microsoft will give to the private cloud servers, they give the Microsoft DNS, which you can resolve anything in the internet. They may not have access to it. So in the cloud, it's a bit tricky because the best way you can do is to control where is your DNS flow goes. So if you're using Microsoft DNS, you don't have much visibility. So the best way to do is to rely on your own DNS infrastructure and then forward it to relay, basically.
Ready now?
I think so.
Cool. All right.
All right. Something is happening here. So as you can see, this was a server, right? So the server detects that there are some chunks missing, and those are the chunks ID. So what start to happen is he start to one by one request to the server, to the client. Hey, listen, I'm missing the 416, send it. Then I'm missing the 1145, send it. And then go on, and that's the reason you see the actually pyramid going down, right? It start to shrink until there's no more missing files. The more missing is basically the client will ask, no answer. That means, okay, everything must be good. Remember that because these retransmission are NSA query, no DNS query, no NS. So that means they get cache. And that could be a problem in the future. So this entry that I'm asking for and I'm getting a reply for is getting cache in my internal DNS, right? With a random, well, not random IP, but an IP address that may not need it in the future. So there's a catch with the TTL caching, right? Normally it is an hour, at least in most DNS. So one issue could be that you send in a file and then you retransmission for it. This is file ID 25. Then a while later, half an hour later, you send another file, and for pure randomness, you get file ID 25. And if you ask for retransmission, you get the wrong chunks because the reply will be cached. It doesn't get to the server. So just be aware of the clashing files within an hour. File ID, which this is randomly generated at the beginning. Every time you run the program, we'll pick it up. Lottery from 0 to 255. Give me, well, 1 actually. So you will pick up just a file ID. So in this case, the last thing you can see, if I scroll back, the CRC of this database was 29B, and the actually server was, it's the same CRC. That means it works. How long it took? I think it was around 280 seconds. All right. How big was the file? Good question. 120K. So this yes, it's not gigabyte speed because it's a DNS is a channel protocol, it's a cover protocol being used. So it's not the massive speed. But again, if you are over 30 and you remember the towns of modems, you will notice that you will appreciate that this is actually okay. But yeah, so let me go back to the slides. So it did work, right? It's done in Python. I think it was, let me see, what I'm using is Scapy and DNS, and of course I'm using the PIS, and this is actually Python 3, by the way. So this is already compliance with the Python going end of life. It's slightly tricky, but yeah, it's Python 3. So I will try to push it to as soon as I get time online. So, you know, it's a POC, right? If you find bugs or modifications or performance, remember, I wasn't a programmer before. I'm still not one of them. So yeah, it works though. It does work. So let me go back to the slides. So proof of concept, check. This went ahead. Now, performance. Right. So this was 120K. It was a 1,000, almost 2,000 packets. And I was using 20 characters, right? I could use 30, but it became a bit more suspicious, maybe too long. So of course, when you more character you use, the speed you get, but also the suspicious you get. So you need to balance the equation there. I'm using a /24, so that means 254 IP address at source IPs, sending data. I'm using 5 data domains and 1 control. Control is actually either the initial packet and the retransmission. So it's basically probably 5 or 6 queries, maybe it was, I can't remember how many retransmission packet, maybe 6 or 7. So what is the result? 270 seconds is what it took for that size files. And I get, this is important, I get 1 to 2 queries. So if you look the log and the traffic, each IP address did 2 queries. Now, you want to go and do, you know, IPSs and NS. So you will see that an IP address did 2 queries to 2 different domains. That's it. That doesn't look suspicious at all, actually. So it's not the same that the one IP address hammering 20 megs of throughput to a DNS server in the internet. That's where the suspicious get. So the whole idea of using the source IP and multiple data domains, first of all, is to avoid getting a spike on the graphics of the suspicious stuff. So this is what they took, 2 queries. Yeah, there's many IPs doing DNS query. And if you look at the DNS logs of the network in any enterprise, thousands of the queries. Plus everything that is wrong configured, actually. So query for control domain is basically 1. And it took, this is actually 4.8 kilobits per second speed. Sure, it's not gigabit speed, but again, if you like phone numbers and BBS, that's what it used to be. You still would. Now, limitations, right? As I mentioned before, I can only send 255, when I say directories, I can only get 255 files at the same time. Why? Because I usually basically for ID identification, I use 00FF. That is basically 0 to 256. So I'm not counting 0. So 255 actually simultaneous files. This is all done threading in Python. So I don't need to specify the files. They are no sequence. They're all in parallel going at the same time. And I'm randomly sending chunks by random sequence of random files. Why? Because that avoid any other pattern. So if you see a DNS query 001, 002, 003, 004, yeah, you can get there's actually a pattern here, right? However, this is random domains, random sequence ID, then at any time, because the whole magic happens in the server. You get all the chunks, then reassemble, resequence them, like that's TCP basically, and then decrypted and et cetera, et cetera, et cetera. And the retransmission, that was a catching problem. So if I send file 50, as I said before, you can actually get, if you ask for retransmission, you get cache on the internal DNS. So just need to wait for the cache to expire, and that it could happen. It's not bulletproof. Right. So where are we going from here? This is very nice, but still I'm basically having 10 domains, 5 domains, 50 domains pointing to one server, right? The NS records of those domain or subdomains point to my server, which is one. So if you do traffic analysis, either there are many different queries to many different domains, still the destination is still being one DNS server in the internet, right? So where we go from here? The DFEx basically is the evolution of DFEx. Is the idea is this is actually, okay, if I'm doing reordering the whole packets anyway, I could easily scale down. I have 10 VN or 20 VPS services across different Amazon servers across different regions even. As long as they have a back-channel communication between them and a master control that can actually synchronize. So each server will receive a piece of a packet. So as long as they synchronize the communication and one guy take care and assemble them, this can easily scale in a distributed DNS file exfiltration. That actually take me away the problem like, yeah, there's only one destination IP, so it's a bit suspicious. Even though it's 50 domains, cloud automation. I want to be able to push that to the cloud, bring up the infrastructure of 50 VPS servers, running the master and control, and run my exfiltration. 3 hours later, take it down. So I want to be able, I don't want to be running this for, it's really ridiculous amount of money, but maybe I want to run it to 2 or 3 hours when I exfiltrate things, when I use it for only that specific. So I want to cloud automation. That's basically a way to actually, scripting in the cloud to put on a deploy, bring up the servers, listening, tear it down. And the last is the CNC manager. So all this automation, all these servers will be a slave, but you still want to see a console manager that will see which bit is getting each to synchronize it, right? So that will take me to my actually last bit, which is your question. Conclusions, right? How do we prevent or detect this stuff? Well, don't allow DNS. That's simple. Unfortunately, half of the world rely on DNS, so it's simple, but it's very hard to sometimes implement. So, okay, so we move into next things. DNS sinkholes. These are either appliance, custom made. What you want to do is all your DNS that don't have an answer come back to you. So you want to analyze the logs. Why? For this point, DNS log analytics. That will allow me to actually see patterns. But it's difficult. So one way to use this is something called entropy. So entropy will give you, from a query name, will give you a category, will give you a risk, an indicator from 1 to 6 if you want to. So google.com will give you a 5. The queries I used before, I give you 1.5. So it gives you different numbers. So doing entropy analytics in DNS logs is something that you can start to see behaviors and something strange going on. So that is one, and very smart people, by the way. You need the people. Don't forget about that one. And last thing you can use, but that doesn't sometimes works, is that's rely for the proxy or internet side, is DNS cloud providers, like Umbrella or Cloudflare. Like those, they have the smart people and the tool building entropy analytics and logs to detect this kind of weird behavior. So one thing I didn't mention before, where do I get 50 domains or subdomains, right? Well, if you go to afraid.org, it's a free DNS provider. Give you 5. You can choose from a list of domains that people put to share. You can choose their 5 subdomains, and you have full control of a DNS server for those 5 domains. However, if you pay $5 a month, you get 100 that you can choose. So it's not really a big investment to have 100 already established domain that someone owns that just delegate you a subdomain, as long as it's available the name, right? And need to be actually 3 letters or longer. So it's not that difficult, because if you go and register 100 domains, first of all, you need to pay them. Secondly, they're all especially very new. So using these kind of existing domains allow you to, well, the domain being from 2008, someone else's domain, you just get a subdomain from it. So I think it's a good method to use for $5. So that will take me to the end and beginning of questionings. What time is it? I think we're good in time.
Yes, we're doing great for time.
Questions?
We have about 12 minutes before
Give
we
me
have
1
lunch.
second. Did I answer your question about prevention and, okay? Yeah? Thank you.
Okay. So before I go to Slido, any questions from, yes, ma'am.
Oh, it's not a question. Wrong spelling, Cloudflare.
Probably.
Yeah. Because it
In
can be
which-
taken as another DNS.
Cloudflare, yeah, good point. Thank you.
Okay, so while I'm on this, the real question is,
Yes.
do you think Cloudflare will die? If so, how soon? Thank you.
That's a philosophical question or political. I don't know if it will die, to be honest.
It is actually technical because I have been examining them for a period of time. I will not voice my view because
Okay.
I'm here to listen to you.
Yeah,
Thank you.
okay. I'm not sure if they, to be honest, if they're going to die, they probably will not tell us because there's action markets and, cloud DNS is being used. And that actually will probably match the first question someone is asking there as well. I don't think they will die suddenly. They may stock price start to go down, the company close, but someone will take over. There's too much data they have already on too much services. So unless they do really wrong things in the business side, well, anything can happen, right? In turmoil, but yeah, it's more political question, right? I don't really have an answer for that side.
Any more questions from the audience? Yes, this gentleman on the third row, blue shirt.
So it looks like this whole thing came out because you have a need to evade the SOC. Is that right? You want to make your request look less suspicious.
Exactly.
So recently, DNS over HTTPS is becoming a thing. Cloudflare actually supports it.
Yeah.
It allows you to make DNS requests
Over SSL,
in
basically.
a post request.
Yeah.
Will your tool support it? Because that would definitely make things a lot easier. In the logs, it would probably look like it's just a request to Cloudflare.
Yeah,
service.
but this is the tricky part, right? Because my tool was designed to work from inside an infrastructure, an enterprise network, right? Where you don't really have access to the internet directly. So for the DNS over SSL or DNS over HTTPS or whatever you want to, that's that kind of size. So it's great idea, but enterprise will not use it. It will not allow clients, endpoints, or piece of servers to directly talk to the internet, transfer DNS over, because they actually want to see what you're doing. So that is great for yourself, privacy inside your home, your laptop, your network, but for enterprise, no. What they may do is they actually use their DNS, the proxy or the DNS server, when need to query the internet. That communication, they may use SSL on it, right? Which for my case, it doesn't matter because that the encrypted part will be between the internal DNS and the cloud DNS. However, the cloud DNS to me is not going to be over SSL because my DNS server is a backward compatibility problem, right? It's like, your DNS is like email. Well, you connect to port 25. Then you ask, you want to start SSL, but maybe the server doesn't support it. So you can choose not to send emails or just switch to not encrypted. So it's a similar issue we have in DNS that we have in SNTP. So I did not test it with actually directly because the problem that I have there is actually the cloud provider DNS, which they probably will realize what's going on with or without the SSL side, right? It's mainly designed to be inside an enterprise network to push files out. In home networks, well, you have already access to the internet, so you can use any other simple SSL tunnels or HTTPS. There's not really much filtering going on in networks that not close, right? Make sense?
Okay.
That answer? Yeah.
Yep. Okay. Thanks.
Okay, thank you. How about, Emilio, you take the top two upvoted questions and then we can decide who will get the prizes.
Anonymous. That is a real anonymous or is it just anonymous?
Sorry? Yeah, they're real anonymous.
Wow.
So they don't get prizes.
I didn't know they were joining.
But because they're upvoted, it's worth answering. Yeah.
Most data center network providers check source IP. Yes. And refuse, maybe that doesn't match. Of course, it's called part of the prefix in BGP to filter that. How the source, because the source IP address is designed to work in a LAN, in an enterprise network, inside your network. It's not designed to actually use spoofing address to the internet DNS. Remember in my slides, some of them. I showed I think it was the lab. On the lab, you will see that it's an internal DNS going to the internet. I'm not going directly talking to the internet because of spoofing will never work, first of all. Probably I don't have even NAT configured to allow my PC to go to the internet. However, the internal DNS is, or you see maybe in a DM set as well, it does have access to go to the internet. So I'm taking the spoofing technique from the 80s inside a LAN because there's no segmentation inside a LAN. It's very weird. Between DM sets, sure. Between the red and the green, sure. But within the green area, within your LAN, it's routing and switching. And spoofing, you can't prevent it from routing and switching spoofing because it's UDP, there's no TCP handshakes. So yes, it will not work directly spoofing to the internet, but it's not designed for that. It's to spoof to the internal IP address of the server. Hopefully Anonymous will say, yeah, thank you. Maybe not.
Okay, and then the next one, is this method affected by DNS switching between UDP and TCP mode?
No, I'm only using UDP mode. The reason behind is because UDP is, you send a packet, if it goes. TCP is being blocked sometimes, and firewalls will only allow UDP. The TCPs normally tend to be used, DNS in TCP is either to sync in zones, or when the packet is too big. So the protocol DNS will switch. But most of the firewalls will probably block TCP 53. Because in reality, a DNS client should not be using TCP unless you're doing zone transferring. So if you properly configure the firewalls, TCP is not allowed. You should not allow it. You should allow only UDP for the reason of that.
I'm going to squeeze in the last question because I'm very curious as well. So macaroni here is IEC powered?
Macaroni unfortunately here I do need this. Singapore has a massive plugs. In Japan we have a very like a US plug. So a power strip fit inside. So the only thing I need to take is from the power strip one cable. Here I need to put a massive power strip outside the box. But it's only 3.5 kilos. So it's easy to portable do a whole infrastructure in a case. I use it for different demo in a armory. It's the same infrastructure I use. You just change the servers. They're all Velcro. It's just a bit difficult to go through custom though.
Yeah, I would think so.
I can imagine.
So,
okay, so Emilio, why don't you choose your favorite question out of the 3 questions that were asked from the floor? And then you can give your prize.
I have 2 favorite questions.
Yes.
One was the first question.
Yes.
I think she deserved
That's her 3rd prize. Well done.
And the other question was the gentleman in the shirt.
Okay.
He has a good point on the
one in the
DNS.
blue shirt. All right.
Yes.
Wonderful.